Hi Math 8 students, today we're going to focus on square roots. To square a number, find the product of the number multiplied by itself. So for example, if I want to square the number 8, I do 8 squared, and that's 8 times 8, which is 64. We've all know how to do that. We've done exponents before, so this is nothing new. To find the square root of a number, for example 16, you must find the number that is multiplied by itself to get that number. So the square root of 16 is 4 because 4 times 4 is 16. The square root of 64 is 8 because 8 times 8 is 64. A perfect square is any number whose square root is a whole number. So, for example, square root of 16 is 4, therefore 16 is a perfect square. Square root of 64 is 8, therefore 64 is a perfect square. So we're going to list all the perfect squares we know from least to greatest. So we could kind of do the math in our head. 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Now, I'm sure you guys all know those ones by heart. Going past that is going to be a little bit harder. And I really want you guys to know up to 20 times 20. So let's just keep going. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 281. 19 times 19 is 361. And then 20 times 20 is 400. So there are some tricky ones in there. But again, if you can memorize those, when you're doing square roots, it's going to make your life a whole lot easier. Oops. So all the numbers in between those listed above are non-perfect squares. We can use the list to help estimate the square roots of non-perfect squares. So the square roots of non-perfect squares are irrational, which is what we kind of saw yesterday without saying it. Some examples are A, square root of 40, and that's going to be between 6 and 7 because it falls between 36 and 49. So I can prove it if I do the square root of 40 on my calculator. I get 6.324555532, which is between 6 and 7. Okay, so we can estimate the square root of 40. And then B, square root of 152, is going to be between 12 and 13 because it falls between 144 and 169, those two perfect squares. Again, I can prove it if I use my calculator and do 152 square root. I get 12.32882801, which is between 12 and 13, and also irrational because it's a non-repeating, non-terminating decimal. So we're going to use that idea to estimate some square roots together. So here I provided the list for you so you don't have to keep going back to find it. So we have to estimate the square root of each of the following, and then we can use the calculator to check our work. So for this first one, square root of 54. 54 falls between 49 and 64. And the square root of 49 is 7, and the square root of 64 is 8. So it's between 7 and 8. Again, we can use our calculator to check. If we do square root 54, we get 7.34846,923, which is indeed between 7 and 8. For the next one, we have negative square root of 13, so we're going to write down our negative, and then we're going to look for 13, or where 13 would fall, and that would be between 9 and 16. Square root of 9 is 3, and the square root of 16 is 4, so it's going to be between negative 3 and negative 4. And again, we can check on our calculator. 13 square root is 3.605555128, which again is definitely between 3 and 4. So when we make it negative, it's going to be between negative 3 and negative 4. The next one we have is the square root of just 132. 132 falls between 121 and 144. The square root of 121 is 11, and the square root of 144 is 12. So the square root of 132 should be between 11 and 12. Again, we can check. If we do the square root of 132 on our calculator, we get 11.48912529, which again is definitely between 11 and 12, and again, definitely irrational because it's a non-repeating, non-terminating decimal. Okay, next we have the negative square root of 89. So we're going to bring down the negative sign. We look for where 89 would fall on our list, and that's between 81 and 100. The square root of 81 is 9. The square root of 100 is 10, so it's between negative 9 and negative 10. Checking our work, square root of 89 is 9.433981113. So definitely between 9 and 10, making it negative, negative 9 and negative 10, and definitely irrational. Next, we have the square root of 38. 38 falls between 36 and 49. Square root of 36 is 6, and the square root of 49 is 7. So this is going to be between 6 and 7. I don't have to use my calculator. I'm pretty sure I got it right. So let's just keep going. Number 6, the negative square root of 98 would be negative. Then we look for 98 in our list. And 98 is again between 81 and 100. Square root of 81 being 9, and the square root of 100 being 10. So it's between negative 9 and negative 10. Hopefully this is making some sense to you. It's not that bad. I think you guys can handle most of this. So you're going to try 7 through 14 on your own. Don't hesitate to ask a question if you're unsure. So then we can have a word problem as well. It says Mrs. Cotton is sewing a square tablecloth that measures 16 feet squared. What is the length of each side of the tablecloth? Well, it's a square, and its area is 16 feet squared. So we want the sides to be the same. So area is length times width, which in this case is going to be x times x equals 16. Well, x times x is x squared. X squared equals 16. So we just have to figure out, well, what number times itself makes 16? Or we can do the opposite of squaring, which is to take the square root, and the square root of 16, which is a perfect square, is 4. So each side of that tablecloth should be 4 feet. Okay, again, hopefully that makes some sense to you because you're going to try another one on your own. Number 16. Again, be sure to ask questions if you're not exactly sure what to do. I'll be around to help you guys out. Good luck.